Hello friends, welcome to the Industrial Automation channel. So in this tutorial I will show you how to connect Delta HMI to Delta PLC as well as Yaskawa VFD. Okay, A1000 is a VFD model and we will connect this HMI to PLC as well as to VFD with RS485 protocol. Okay, let's see. So first of all, we need to connect PLC and VFD to HMI. Okay, so in Delta HMI, just a minute, I will just zoom it. So in Delta HMI we have we have three COM ports. Okay, this is one DB9 connector and this is one DB9 connector. So here this DB9 connector is for COM1, okay, and this is for COM2 or COM3. You can see here there is written COM2 or COM3. Okay, so we will use this COM2 and COM3 port for communication with PLC as well as VFD. So I will show you how we will configure, how we will do wiring for this DB9 connector. Yeah. So we need male DB9 connector to connect to this port COM2 or 3. Okay. So these two ports COM2 and 3 are in single port. Okay. So we need only one DB9 connector for this port. Okay. So for this we have pin number 1 and pin number 6. We need to connect this pin number 1 and 6 to PLC. Okay. This is 14SS2 PLC and you can see this is downside of the PLC. One connector is there for RS485 communication. If you see here RS485 is written. Okay. So pin number 1 and 6 is for COM2. Okay, and pin number 4 and pin number 9 is for COM3. So pin number 1 is plus, you need to connect this to plus 485 to this, and pin number 6 to minus of this PLC. Okay, then pin number 4 you need to connect to this is VFD, Yaskawa A1000 VFD, and over this VFD you can see this terminal S minus, S plus, R minus, R plus. These are the basically for RS485 port. Okay, so we will connect pin number 4 to this S plus. Okay, and S plus and R plus need to be short. Okay, these are the you need to connect these two, S plus and R plus. And then pin number 9 is minus, and this we need to connect this to the R minus, and this R minus and S minus need to be connected. Okay, so in short, 1 and 6 is for COM2, and we are going to connect PLC on COM2, and on COM3 we are going to connect to VFD. Okay, let's go ahead. Now these are the communication parameter of Yaskawa VFD. Okay, if you will see the manual of A1000 VFD, I have already opened that. So here it is Modbus communication details in appendix C. Here you can see the communication specification. So it supports RS422 or RS485 communication. Okay, communication cycle is asynchronous mode. Then we can see the communication parameters here. So we can set baud rate, multiple baud rate as shown here. Data length is 8 bit. It should be fixed. Parity is even, or you can change as odd or none. stop bit is 1 bit. These two parameters are fixed. One is data length and second one is a stop bit. Okay. Protocol, Modbus or Modbus, RTU mode only. Okay. We can connect multiple drives to one master protocol. So in this HMI we can connect total 255 Modbus slaves. Okay. So these are the communication specifications for Yaskawa VFD. So these are the some parameters you need to set, okay, in VFD. So in H501 parameter, this is the slave address. Okay. So for PLC we have slave address 01. So for VFD we will set it as a 2. Okay. For first VFD. For second VFD we need to set as a 3. For next VFD you need to select as a 4. In this way you can you can connect multiple VFDs. H502, this is actually COM speed, that is baud rate. So I will select 03. 03 means 9600. Okay, you can see these all these parameters in manual. Okay, in this manual you will see all these settings. I will just show you. Yeah, here you can see H5001. H501, it means drive slave address, and this is H502 parameter. So we are here H502 parameter. So in H502, if you set it as a 0, it means 1200 baud rate. So I selected as a 3, it means I have selected 9600 baud rate. Okay, and third one is a H503. I have entered one value. 1 means even parity. You can see in manual. So this is H503 parameter. In this parameter you can see 0 means no parity, 1 means even parity, 2 means odd parity. So I have selected, you need to just select 1, it means even parity, right? And one more setting you need to do. So if you want to control the VFD from PLC or HMI, there are two methods. There are two things. First one is you can just change the frequency from PLC or HMI, and second thing, you can also give the run command from PLC or HMI. So in this application I will just show the frequency. We will just set the frequency from HMI and we will see the actual current only. Okay, so run command, it will be on terminal. So in B01 parameter you need to just set as a 2 for Modbus. So it means the frequency reference selection is on Modbus. Okay, so for run command, I am not going to select as a 2 because I don't want run command from Modbus. Okay, so better way, so run command is from terminal. Yeah, so let's go ahead to HMI programming side. So I will just open the DOP soft. Okay, just create new project 107. Let's select 107 CV, which is economic model. Next. Yeah, now here you can see COM2 and COM3, COM1, COM2, COM3, right? So I will just show you what is this. This is COM1 and this is COM2 and COM3. Okay, both COM are inbuilt in this one port. So on COM2 we are connecting PLC on COM2, right? This is COM2 1 and 6 number, so we are connecting PLC here. So I will just select here PLC, Delta make, Delta DVP PLC. I will select it as a RS45. Okay, rest things are the same. 7 bit 19600, even PLC station will be 1. Okay, so next part, that is COM3, right? So for COM3 I will just select connection here, and we need to select here Modbus. So I will select Modbus. In Modbus I will select RTU hex master, hex address. This is RTU hex address master. Okay, the interface will be RS485. So data bit 8 bit, stop bit 1 bit, baud rate 9600 and parity even. Okay, and just change the PLC station to 2. Click on finish. Yeah, so this is our screen 1. So now I want to change this. Suppose I want to change the speed of VFD. So I will take one numeric input, numeric entry. This is numeric entry. I will just double click. Let's give the address for this numeric entry. So for addresses, I will just show you what are the addresses for Modbus. So in manual you can see all addresses here. Okay, these are the Modbus data table. So addresses which are given in this table are possible to both read and write. We can read and write these addresses. So this first address, that is 00H, is a reserve. 01 is for start command, stop command. You can see here forward run, reverse run. Okay, we are going to take frequency reference. So we will take the address 2H, right? So read write 2. So if I select, we have link 3 for VFD. Here select as a read write and address is 2. Enter. Just copy this address and paste here. Yeah. Here we will take fractional 2. Okay. So frequency which we are showing or which we are giving to the VFD will be in fractional, and don't change here anything. So it will be word, unsigned decimal, and fractional to integer digit 2. Just click OK. Okay, minimum maximum error. Here we will just select as a 99.99. Okay. Now you can see this is 2, right? Link 3, and this 2 shows VFD which have slave ID of 2. If you have multiple VFD, if you have one more VFD, then we will just copy this and we will do the 3 here. We will change to 3. It means this VFD has a slave ID of 3 number, right? Okay, so we have taken address read write 2, it means it is frequency address. So whenever you will enter any value here, it will go to VFD, okay, and the frequency will be set to VFD. So for current, we will take one data display, numeric display. We will give the address. Let's check the current address. So current will be only read address. So we'll check in another table. So these are the only monitor data, right? So here you can see which is the current address. This is output current, okay. So 26 is a current address. So let's take 26 here. Link 3. Read write 26. Okay. Here we will take as a fractional 1 digit. So for current it is 1 offset, and for frequency it is 2 offset. So for second VFD, we will select here as a station 3. So this is current display for VFD 2. Okay. So if you want communication any numeric entry for PLC, so we'll just copy this numeric entry. So for PLC you need to just select here link to any D address, suppose 100. So this is for PLC numeric input. Okay, this is just taken for example. So these are the set frequencies for VFD. These are the actual current for both VFD, and this is one numeric entry for PLC. So if you want to take this frequency and actual current in PLC register, then how you can do it? So you just need to write some micro here. So just go to option, click on background micro. Okay, macro wizard. So here we want to move the data. So select data transfer, move. Okay, so variable 1. So for variable 1 is destination, means we need to take here PLC address. Suppose let's take D200, enter, and variable 2 is a source. So if we want to move this set frequency to PLC address, right? So we'll just select here set frequency address, go to link 3, and we have frequency address is 2, enter, update macro. So this is how micro will look. Okay, it means the data which are available on link 3 station 2, that means VFD 1, this is VFD 1, frequency value will be moved into D200 register of PLC, okay, which is connected on link 2. So same if you want to move data for next VFD, so we will take as a M20 suppose 2, and here it will be a 3. It means frequency of this VFD2 is moving into D202. Okay, in this way you can move the actual current in one register also. Okay, Okay. Suppose you want to move the current, so I will just copy this macro, will paste here. Let's take suppose D204 and rewrite 26. This is current. So in this way, let's check the update the macro. Yeah. So in this way you can move these values from HMI to PLC. Okay. So in this way you can connect to Yaskawa Make VFD or any other Make VFD which supports to Modbus. Okay. And you can communicate to VFD plus PLC. Okay, as shown in this first diagram, you can communicate to multiple VFDs and with PLC parallelly with Delta HMI on RS485 cable. Okay, if you have any error in the program, or if you are facing any problem for during the commissioning, just comment below. I will give you the perfect answer, or I will try to give the answer. I will try to solve your problem. Okay, so please like, subscribe our channel for more technical automation knowledge. Okay, and thanks for watching this video.